Recently, the President of the United States, Donald Trump, announced the Golden Dome, a bigger and better version of Israel's Iron Dome, which would aim to protect the country from the increasing ballistic threats from states like Russia, China, and maybe even North Korea. It has been widely compared to the Star Wars program from the 1980s during the Reagan era, but is it just more of the same? Is it viable? Let's take a look at that in today's video. But before we do, don't forget to subscribe to the channel and share the video with everyone you know to help the World Geopolitics channel keep growing. And consider becoming a member. Becoming a member of the Geopolitics channel is no small thing, unlike most channels on YouTube. You become part of a large community of people who are passionate about geopolitics and extremely qualified. In addition to having access to the channel's exclusive content, you'll also get access to exclusive live streams with me and early access to videos that are later released to the public. And most importantly, you ensure that the Geopolitical Mundial channel stays alive and true to its methodology without having to worry about chasing views on YouTube, thus preserving the channel's integrity. I'm Adriano Pita, and you're watching the Geopolitical Mundial channel. Imagine that tensions between the United States and a nuclear-armed adversary are escalating. The threat to the United States from miscalculation or intentional action increases every day. Then suddenly, American satellites equipped with infrared cameras detect the smoke from dozens and dozens of intercontinental ballistic missiles. These tracking satellites then activate the nearest interceptor carrier satellites, like the algorithm of a ride-sharing app like Uber, so to speak, finding the closest driver. The interceptor rockets are then launched and accelerate to hit the missiles, destroying them like bullets destroying bullets. In this hypothetical scenario, the United States prevented a catastrophic attack on its territory and potentially avoided a nuclear apocalypse for the entire world. This is how the Trump administration's plan for a space-based missile defense, or the Golden Dome, could work, although it is still only a hypothetical capability. This process is the militarization of outer space, which some call astropolitics, but the correct term is meta-geopolitics because it involves more dimensions. That's not our focus today. If you want future comments on this, leave it below. Now back to the project. Golden Dome is a proposed anti-missile defense shield by the United States. For the first time, it places armed interceptors in space. To protect American territory against ballistic and hypersonic missile attacks, it is a multi-layered and integrated system designed to neutralize threats in all phases of a missile's flight, from before launch through surveillance and possible preemptive strikes, to the boost phase, the mid-course spaceflight phase, and even the terminal re-entry phase into the atmosphere. The Golden Dome aims to leverage a network of hundreds of satellites distributed around the globe, equipped with advanced sensors and interceptors capable of detecting hostile launches in countries like China, Russia, North Korea, or Iran, and engaging the missiles right after launch. This space architecture would add an initial layer of interception to the United States' missile defense system, complementing the ground-based interceptors that already exist in California and Alaska. Originally conceived during the Trump administration, the Golden Dome was described as an aerodome for America, in analogy to the Israeli system, although much broader in scope and technology. According to official statements, the goal is to complete the work started by President Reagan 40 years ago, referring to the Strategic Defense Initiative, the Star Wars project from the 1980s. The difference is that today, the technology of massive satellite constellations and advanced microelectronics opens up possibilities that were unfeasible in the 1980s for space interceptors, including non-kinetic options, like laser weapons to shoot down missiles right after their launch. In May 2025, The presidency estimated the initial cost of the program at about $175 billion and appointed the Space Force as the leader of the effort, indicating the urgency and priority given to this unprecedented defense project. To enable the detection and tracking of threats, the Golden Dome relies on a sophisticated architecture of space sensors organized in layers that work in a coordinated manner. The first layer consists of infrared warning satellites, also known as the Space-Based Infrared System, which are satellites in geosynchronous orbit that provide early warning of missile launches by detecting the heat from boosters when a missile enters its ascent phase. These satellites in geostationary orbit, positioned at 36,000 kilometers altitude, can identify the launch point and estimate the missile's initial trajectory and likely warhead impact zone. However, they offer very limited resolution for precise tracking, so the plan is to complement this initial warning with a constellation of low-orbit satellites for continuous monitoring. Next, we have the tracking layer, consisting of dozens of satellites that will be expanded to more than 100 small satellites in low Earth orbit, dedicated to tracking advanced threats during flight. These satellites carry medium and wide field of view infrared sensors, capable of tracking both ballistic missiles and maneuverable hypersonic vehicles after their boost phase. The Space Development Agency has already begun deploying this layer within the so-called Proliferated Warfighter Space Architecture, which stands for Proliferated Warfighter Space Architecture. By launching batches of tracking satellites, the Tranche 0 model, still experimental, placed satellites in 2023 for testing, and Tranche 1 plans for 28 satellites in 5 orbital planes at about 1,000 kilometers altitude by the end of 2025. In future configurations, the tracking layer could surpass 100 satellites in low orbit, probably adding satellites in medium orbit to improve global coverage and tracking persistence. This network will provide global alert and real-time custody of enemy missile trajectories. Some of these tracking satellites carry high-resolution sensors and fire control accuracy. For example, sensors with smaller apertures, but capable of refining tracking to guide interceptors. Then we have the custody layer, another constellation of satellites designed to include intelligence, surveillance, and reconnaissance satellites in low orbit to maintain continuous surveillance 24 hours a day, 7 days a week, of time-sensitive and mobile targets in adversary territories. In other words, the custody layer aims to observe where the enemy's assets are in real time, including mobile missile launchers, launch bases, convoys, and other assets that precede an attack. This continuous surveillance would, in theory, allow the detection of enemy launch preparations well in advance and, with that, quickly transfer target data to interceptors or to preemptive strike weapons. So we also have the crucial hypersonic missile tracking sensors. In coordination with the tracking layer, the United States Missile Defense Agency is developing the Hypersonic and Ballistic Tracking Space Sensor, which stands for Hypersonic and Ballistic Tracking Space Sensor. It's a set of prototype satellites in low orbit equipped with infrared sensors with a narrower field of view and high resolution. They're described as the sniper's high-precision scope. It's capable of discriminating and accurately tracking warheads or hypersonic vehicles amid countermeasures, providing fire control quality data for the final guidance of interceptors. 2 hypersonic and ballistic tracking space sensor demonstrator satellites were launched in 2023 and 2024, along with the Tranche 0 that I mentioned. It is expected that in the future, hypersonic and ballistic tracking space sensor, type sensors, will be integrated into the already operational constellation, so that each tranche of tracking satellites will include both warning and acquisition sensors, as well as tracking refinement sensors. Lastly, the communication and command network. Although it is not a sensor, it is worth mentioning because all these space layers will be interconnected by dedicated communication satellites and by optical crosslinks between satellites, supposedly ensuring that detection and tracking data are quickly shared and sent to command centers and interception units. But then comes the big difference of the Golden Dome, which are these space interceptors that have been proposed. The boldest element of the Golden Dome is the constellation of space interceptors designed to destroy enemy missiles in the boost phase, that is, at the moment when they are accelerating, in the few seconds or minutes after launch. Unlike current systems that intercept warheads in space or during re-entry, already well advanced in their trajectory, the idea here is to attack the missile while its engines are still firing, and it is ascending through the atmosphere at a time when it is relatively slow, bright, and more vulnerable to being neutralized, before releasing the warheads or countermeasures. The plans indicate two main types of engagement from space: orbital kinetic interceptors, which would be small missiles or impact vehicles housed in low-orbit interception satellites. Upon detecting a hostile launch, the nearby satellite would launch an interceptor vehicle that descends toward the ascending missile, guided by infrared sensors and possibly remote assistance from tracking satellites. The interceptor would collide with the target at high speed, destroying it through kinetic energy without an explosive warhead. The orbital interceptors would have to be extremely fast and maneuverable, therefore having their own propulsion system sufficient to adjust their orbit and dive into the atmosphere against an ascending target. Estimates suggest extremely high accelerations and terminal velocities, because there are only a few dozen seconds available to intercept an intercontinental ballistic missile during this boost phase. Each satellite is expected to be able to carry one or multiple interceptors on standby. They would have their own search sensors or receive information from tracking satellites, and once launched, they would automatically guide themselves to the impact. It's important to make it clear here that no space interceptor of this kind has been developed yet. Even official documents acknowledge that orbiting interceptors are advanced elements that still need to be developed. Even so, the American government believes it will begin testing in the coming years and will have an initial capability before 2030. But then we also have the extreme end of expectations, which are directed energy weapons, also known as space laser weapons. The Golden Dome also mentions these non-kinetic options for interception, which is understood to mean the use of high-power orbital lasers. In this scenario, satellites equipped with high-energy lasers would aim a concentrated beam at the missile right after launch, heating and degrading its structure until it causes a catastrophic failure. A laser travels at the speed of light, which avoids flight time issues, and could theoretically hit targets over different parts of the world almost instantly. But the technical challenges are absolutely colossal because it would require a very high-power laser system and large aperture optics to focus the beam hundreds or thousands of kilometers away. Besides that, it would demand a huge power source on board the satellite. We're probably talking about a compact nuclear reactor or absurdly large solar panels, with energy storage, as well as an advanced targeting and stabilization system to hit a fixed point on a missile accelerating in dense atmosphere. During the Star Wars initiative in the 1980s, they considered space-based chemical lasers and neutral particle beams, but it never went beyond the experimental phase. Today, it's believed that with advances in high-power solid-state lasers, this could become viable in the future. A smaller and more efficient space laser could become possible, especially since Donald Trump explicitly requested studies on orbital lasers as part of the Golden Dome, recognizing this possibility of instant energy strikes. In practice, a laser requires the satellite to have an unobstructed line of sight to hit the missile, with no dense clouds in the way, although firing from above down through the stratosphere makes this somewhat manageable. It also needs to keep the beam on the target for a few seconds to deposit enough energy to destroy it. So far, no orbital laser system capable of generating that much energy exists, but research in optical materials, adaptive optics, and energy distribution may make this option feasible only in the long term. If successful, this would be a laser that could engage multiple targets in rapid succession, unlike the kinetic interceptors I mentioned, which are consumed upon use. And we have the most basic and already existing line, which would only be improved, which is the cooperative interception layer of lower layers. If a missile is not destroyed during the boost phase by the space layer, the Golden Dome then provides for engagement with ground-based mid-course interceptor missiles. This includes current missiles as well as future American hypersonic missiles that are still being developed, which could attempt to destroy the warhead in outer space. In addition, a terminal layer within or around American territory itself is being considered, such as the project that mentions installing interceptor batteries on United States soil, similar to the STAD system or Aegis Ashore, for a last effort against warheads that managed to penetrate the previous layers. This integration of air, sea, land, and space would allow the shield to engage everything from intercontinental ballistic missiles to hypersonic glide missiles, including advanced cruise missiles that fly within the atmosphere. The effectiveness of space interceptors will also depend on the orbit in which they are positioned and the orbital geometry in relation to enemy launch theaters. There are essentially two orbital options to keep satellites over target areas, either very high altitudes such as geostationary orbits or low altitudes. Each approach has its own different physical advantages and limitations. In the case of geostationary orbit, a satellite remains fixed over a point on Earth, which would be ideal for constantly monitoring a region of interest. For example, keeping an interceptor always stationed over the launch fields of China or Russia. However, the enormous altitude brings two serious problems: distance and interception time. The interceptor launched from this type of satellite would need to travel tens of thousands of kilometers to reach a missile ascending near the surface. Considering that the boost phase of an intercontinental missile lasts about 3 to 5 minutes, a missile launched from a geostationary satellite simply wouldn't arrive in time. And, in the case of low-orbit satellites a few hundred to up to 1,000 kilometers high, to place interceptors close enough to the targets at the right time, the solution would be to keep them in low orbits around the Earth. In low orbit, satellites orbit within a very short time window, from 90 minutes to a few hours, and pass over different points on the globe. The low altitude reduces the distance to a missile right after launch, making it feasible to reach the target within a short period of time. But the disadvantage is that no individual satellite could remain over a single location for very long, since they are just passing by, so to speak. To ensure continuous coverage of a specific region, a very large number of satellites will be needed, distributed in different orbits and planes, so that there is always at least one or several over any possible enemy launch site at any given moment. And as always, geography will play a crucial role both in the design of the Golden Dome and in the challenges of its operation. The location of enemy launch sites, such as the countries targeted by the system, China, Russia, North Korea, and Iran, have different geographic configurations that affect defense. In the case of China, its intercontinental missile launch sites and intermediate-range missile bases are spread throughout the interior of the country, some in remote northwestern deserts, such as in the deserts of Gansu and Xinjiang, where intercontinental missile silos have recently been built. Covering launches in the heart of mainland China is difficult, because a space interceptor would have to be almost directly over the Gobi Desert region at the exact moment of launch in order to intercept during the boost phase. And as I mentioned before, this will require a dense constellation of satellites. In Russia, the intercontinental missile silos are widely distributed in areas like the Urals and Siberia at high latitudes and some thousands of kilometers from the coast. Russian missiles on a polar trajectory can be launched far to the north, which means that additional interceptor satellites in polar orbit will also be necessary. In addition, Russia has extensive submarine missile capability in the Arctic and Pacific areas, creating attack vectors from the north or west. Thus, to defend against all Russian trajectories, the Golden Dome would have to cover virtually the entire northern hemisphere of the planet. In both cases, the territorial depth of China and Russia means that interceptors based outside their territories, even if orbital, have very large distances to cover. Unlike, for example, the defense of a small country like Israel with the Iron Dome. And even so, we saw that some Iranian missiles, in fact several, managed to break through the defenses and hit Israeli territory. But here, the continental scale of the aggressors makes the geometry much less favorable for the United States. And the flight paths and interception angles of an intercontinental ballistic missile launched from Asia to the United States typically travel over the Arctic due to the curvature of the Earth. This means that interceptors positioned in polar or high-latitude orbits will have the primary chance of engagement. Missiles from the Middle East, such as from Iran or from South Asia, may come from more direct trajectories through the Eastern Hemisphere. In other words, in all cases, the engagement window occurs over enemy territory or adjacent international areas. Regarding the launch bases for the interceptor satellites, from the American point of view, the logistics of launching the hundreds of Golden Dome satellites is also geographically conditioned. The United States will use two spaceports, Cape Canaveral in Florida, for insertion into medium and high inclination orbits, including polar, via south-north launches, and Vandenberg Base in California for polar and retrograde insertions. In addition, some international alliances will also be leveraged, with an invitation extended to Canada to join the Golden Dome. In fact, without Canada, the Golden Dome simply won't be realistic. And, above all, the recent subject of controversy, Greenland. Supposedly, once operational, the Golden Dome would automatically cover large areas of the globe, which means that other countries could benefit, let's say, for free from this protection. With that "for free" in huge quotation marks, I say this because the protection will come at a very high political price. But ironically, the financial estimates are astronomical. Strategic studies have suggested high numbers, something around 1,000 to 2,000 interceptors in low orbit, while an analysis by the National Academy of Sciences considered a more limited and smaller system, requiring hundreds of interceptors and costing around $300 billion to be implemented. The Trump administration projected a cost of approximately $175 billion to develop and deploy the Golden Dome, intending to complete the essentials within 3 to 4 years. What I must emphasize is that it's unfeasible and it's not going to happen in such a short time, especially because documents from the United States Congressional Budget Office indicated that just the space components of the shield could cost up to $542 billion over 20 years. This amount includes maintenance, satellite replacement over time, and ongoing technology development. In other words, $500 billion to maintain a robust defensive constellation in space. Just for comparison, the entire annual budget of the Pentagon in 2025 is about $850 billion. It's a colossal amount with no return. There's still a problem because it's a project that's vulnerable to anti-satellite weapons. Because any satellite, especially a bright or large interceptor, can become an easy target for anti-satellite attacks. And both Russia, China, and India have already demonstrated the capability to destroy satellites in low orbit. That's why, on one hand, the idea might seem good, but on the other hand, putting weapons in orbit makes them vulnerable targets. And an adversary could accelerate the space arms race precisely by developing ways to quickly take down these interceptors. Furthermore, The destruction of dozens or hundreds of satellites in low orbit would create clouds of orbital debris, something known as the Kessler syndrome, which could damage other civilian and military satellites and worsen space security in the long run. And of course, the adversaries of the United States could still partially bypass the shield by investing in long-range cruise missiles launched from submarines near the United States coast, flying low, out of sight of sensors, almost all the way to the target, or even non-ballistic devices like hypersonic gliders that deliver warheads through unpredictable trajectories. But most importantly, as I have said many times here on the channel, the fundamentals of geopolitics are action, reaction, and precedence, and putting weapons in space breaks with the traditional caution that the United States and other powers have maintained since the end of the Cold War. Because even though this does not violate current treaties, China and Russia have denounced the Golden Dome as destabilizing and as proof of the United States' intention to militarize space. And therefore, they would also have to follow this path. In other words, there is a risk of triggering an orbital arms race, with each side deploying weapons and counterweapons in space, eroding the last remnants of limitation agreements. So, for me, the chances of the Golden Dome actually happening as it is are very, very small in 20 years, and practically zero in 4. It seems to me like another repetition of the same American habit of complicated approaches with absurdly expensive costs to solve military and geopolitical problems, which is a strategic mistake that I believe will be fatal for Washington, which should be more concerned not with expensive and complicated solutions, but with how to lower the costs of war without reducing effectiveness and quality. Even though, in fact, part of the future of geopolitics will be meta-geopolitics, outer space, the real race that I see beginning and that the United States is ignoring is the lowering of the cost of war. Thank you all. I hope you enjoyed it, and don't forget to share the video with everyone you know to help the World Geopolitics channel keep growing. Hugs, and see you in the next video. Thank you.